All right, we're in section 10.2 where we're going to use combinations and the binomial theorem. So in 10.1, we talked about permutations. Permutations were when we talked about arrangements where order was important, and combinations is talking about an arrangement where order is not important. Basically, when you are dealing with either a permutation or a combination, you are trying to figure out which formula you need to use. So when we looked at permutations the other day, permutations with n and r, which meant the same thing, that equation was n factorial divided by n minus r factorial. So the only difference between the permutation and the combination in the formula sense is we have that extra r factorial in the denominator. Because of that extra r factorial in the denominator, most of the time when n and r are the same thing, the permutation is going to be the larger number or the larger number of outcomes because of that order importance. Okay, so looking at some combination situations, let's take a look and see how many possible outcomes there are for these problems. So it says you are picking 7 books from a stack of 32. If the order of the books are chose is not important, how many different uh, 7 book groups are possible? So we have a combination because it said that order was not important, and we have 32 objects, and we're trying to arrange them 7 different ways or 7 possible ways. So using the formula, it's going to be 32 factorial divided by 32 minus 7 factorial, and it gets multiplied by r factorial, which is also 7 factorial. All right, so what I like to do first is I like to subtract the 32 minus 7, and in this case it's 25. So I get 32 factorial divided by 25 factorial times it by 7 factorial. Okay, the reason I like to do that is this is I'm sure nobody, including myself, doesn't like to expand a really large factorial. So in this case, this would be 1 times 2 times 3 times 4 times 5, all the way up to 32. Okay, it's a lot of stuff to write down, and eventually you're just going to cancel things out anyway. So I see that my larger number in the denominator is 25. So between the products of 1 times 2 times 3 times 4, all the way up to 25 get canceled. So the only thing that I really need to write in the numerator is 26 times 27 times 28 times 29 times 30 times 31 times 32. And the only thing I have to write in the denominator is this 7 factorial, which is 1 times 2 times 3 times 4 times 5 times 6 times 7. Multiply everything in the numerator, multiply everything in the denominator, I get a total possible outcomes of 3,365,859, or 56, sorry, 856. Okay. Now, we have some combination phrases that we're going to take a look at, and we are going to utilize different operations that are going to help us find the possible outcomes because they have different objects in different number of arrangements depending on what the question is asking of you. Okay, so if you look at uh, these combinations here where it says look at the phrases at least, at most, and exactly. Anytime you're looking at the term exactly, we're going to be dealing with some kind of a multiplication problem. When we're dealing with a problem that says something as at most, it's going to be dealing something with an addition sign. When we're looking at least, technically it's an addition sign, but we're also going to be doing something with subtraction. I'm going to show you what that looks like when that example arises. So here it says that a local movie rental store is having a special on new releases. The new releases consist of 12 comedies, 8 action semi-drama, 5 suspense, and 9 family movies. It says you want exactly 2 comedies and 3 family movies. How many different movie combinations can you rent? So it's a multiplication problem and has 2 separate situations because we have a combination of 12 possible comedies, but you're going to get exactly 2 of them, and it gets multiplied by, uh, we have what, 9 family movies to choose from, and you're going to get exactly 3 of them. So, looking here, we're going to look at 12 combination of 2. That gets you, when you do all the math, you get 66. And then when you have 9 objects with a combination of arrangements of 3, you get 84. So now you're going to take 66 times it by 84, and you get 5,544 possible outcomes for exactly 2 comedies and exactly 3 family movies with the choices that we have. For part B, it says you can afford at most 2 movies. How many movie combinations can you rent? If you look up here, we give you some more specifications when you use the word at most. All right. So it says that problem solutions need to include the possibility of selecting 0 objects. So it says 2 movies. It doesn't give any type of genre, so it's just the total number of movies that that rental store has, or at least in what we're looking at. So 12 plus 8 plus 7 plus 5 plus 9. That means there's 41 total. So and when we talked about at most, we're talking about an addition problem. So we're going to look at a combination where we have 41 choices and we got 0 because that's a possible option, plus a combination where you have 41 and 1, plus a combination of 41 and 2, because it's at most, because you can have those situations there. So that's going to equal, so the combination of 41 and 0, the result is 1, plus the combination of 41 and 1, which is 41, plus the combination of 41 and 2 gets us 820. When you add all of those up, we get 862 possible outcomes. Okay, so the last one here, it says find the number of possible movie combinations if you can choose 2 action movies and 2 dramas. So this, even though it doesn't say it's an exact answer, it doesn't say at most, at least. So they're looking for 2 action, 2 dramas. So this is a multiplication problem. So this is a combination where we have 8 action movies and you're getting 2 of them, times it by the combination of 7 dramas and you're getting 2 of them. So when you do all the math, combination of 8 and 2 gets us a value of 28, times it by 7 and 2 gets us a result of 21. Multiply 28 times 21, you get 588. Okay. Last question on this page. It says here, a popular magazine has 11 articles. You want to read at least 2 of these articles. How many different combinations of articles can you read? All right, so here it says for each article, for each of the 11 articles, you can choose to either read or not read the articles. So there are so many different combinations. So here's how you define or how you tell how many different combinations are there. You're going to take 2, which stands for whatever, stands for any value in this, and you're going to raise it to how many objects there are. So since there are 11 objects, you're going to raise it to the 11th power. When you have 2 to the 11th power, in this case, you have 2,400 or I'm sorry, 2048 possible outcomes, all right? If you were to read, you know, every single article or so here's how we find, depending if you just read one article, where we read two articles, where we read three articles, four articles, five articles, stuff like that. Okay. So here is how um, you can go about it. You can go about it two different ways to solve this problem where it's at least two. All right. You could make it into an addition problem and say, all right, I want to do the combination of 11 and 2 plus the combination of 11 and 3 plus the combination of 11 and 4 plus combination of 11 and 5 plus the combination of 11 and 6 plus the combination of 11 and 7 plus the combination of 11 and 8 plus the combination of 11 and 9 plus the combination of 11 and 10 plus the combination of 11 and 11. All right, that seems like a lot of work to do. And when you do all the math and stuff like that, the result is 2036. All right. There is another way of going about doing that, and it's how it's utilizing this number. Okay. So we can say that 2 to the 11th power is 2048. What we're going to do is we're going to subtract it to the ones that we know we're not going to do. So we're just going to look at the combinations where we have 11 and 0 plus the combinations where we have 11 and 1. All right. So that's the ones we don't have. And this is going to be 2048 minus 11 and 0 gives us 1 plus combination of 11 and 1 gives us 11. So 11 plus 1 is 12. 2048 minus 12 gives us the 2036. Okay. So same answer, a lot less work. Okay. So using that same idea, it says your school's football team has scheduled 10 games for the season. You want to attend at least 4 games. How many different combination of games can you attend? So you can attend 2 to the 10th power. So 2 to the 10th power games. So if I go 2 to the 10th power, that means that we have 1,024 possible outcomes of you attending these football games. Okay, but they want you to attend at least 4 of them. So what we're going to do is we're going to take that 1,024 and subtract it by the ones that we're not going to do. So we know that we're not going to attend 0 games. So we got 10 and 0 plus 10 and 1 plus 10 and 2 plus 10 and 3, because we already established you want to go to at least 4. So these ones are not part of the possible outcomes for this situation. So what we're going to have is 1024 minus, this turns to 1 plus 10 plus 45 plus 120. So I have 1 plus 10 plus 45 plus 120. That gets you 176. So it's essentially 1024 minus 176. And the result is 848 possible outcomes. Okay. So here it says, out of finalists, your class has to choose 3 class representatives. You want to find the number of combinations of 3 students who've been chosen as representatives of the 5 finalists. Again, this is where they're saying that n is 5, r is 3. Just utilize the formula. 5 factorial over 5 minus 3 factorial times it by 3 factorial. Remember now this, when 5, if you get this turns into 5 factorial on the top, this turns to 2 factorial times it by 3 factorial. Now the 3 factorial is the one that's the largest value, so 1 times 2 times 3 both get canceled, so it's just going to be 4 times 5 on the top and 1 times 2 on the bottom. That's where we get 10 combinations. Okay, so well, actually what we're going to do now is kind of look at Pascal's triangle and show you how Pascal's triangle can be utilized with combinations. So Pascal's triangle simply means this. You're going to have ones on the outside of each one of these pyramid values. Once you have the ability to write something in the middle, it's the sum of these two values. So that's why we have 1 plus 1, which gives us 2. We go to the next row, 1 goes to the outside, 1 and 2 gives us 3, 2 and 1 gives us 3. We go to the next row, this is going to be 1 and 1, this turns to 4, this turns to 6, this turns to 4. Going to the next one, this is 1, this is 5, this is 10, this is 10, this is 5, this is 1. So that is how we can utilize these different problems. So this is row 0, this is row 1, this is row 2, this is row 3, row 4, and row 5. So if you look here in the 5th row, this one has a combination of 5 to 1. That result should be 5. All right, so that's where that comes from. If you looked at 5 and 2, 5 and 2 should get us 10. Also 5 and 3, so that's where we can get those numbers. Well, how Pascal's triangle is useful is we can utilize it for a binomial theorem. So instead of expanding uh, any type of polynomial and multiplying out using some kind of FOIL or some kind of multiplication, we can utilize Pascal's triangle with those combinations and use this formula. Okay, so what we're going to do is we are going to look at 2m plus n raised to the 4th power. So here's what we got. So since it's the 4th power, that means we're going to use the 4th row. So here is our 4th row. So the 4th row has values of 1, 4, 6, 4, and 1. Okay, so basically what we're going to do here is you are going to take, utilizing this formula up here, you're going to take whatever n is 4, and you're going to take the combination of 4 and 0, which is 1, which is where it is right there, and you're going to take the first term, which in this case is 2m, raise it to the 4th power, and you're going to take the second term, n, and raise it to the 0 power. Then you're going to add it. You're going to take the combination of 4 and 1 now, which will be 4, and now you're going to take 2m, you're going to decrease this 4 and turn it to 3, and you're going to increase this 0, so its n becomes 1, plus combination of 4 to 2, which should be 6, and now I got 2m, decrease that, so this turns to 2, n gets increased by 1, so that becomes now to the 2nd power, plus combination 4 to 3, I got 2m, raise that to the 1st power, and now I got n, add that, raise that to the 3rd. Finally, we have combination of 4 and 4. I got 2m raised to the 0 power, and I got n raised to the 4th power. Okay, so here, this turns to 1, and then this turns into 16m to the 4th, and then n to the 0 is just 1, plus c to the 4, 1, that, like I said, was 4, so this is going to be 4, times it by 8m to the 3rd, and then it's n, plus C42 is going to be 6, so now I got 6, and that gets multiplied by 4m squared n squared, plus 4, 3, which is 4, times it by 2m n to the 3rd, plus 1 times 1, and that's n to the 4th. So now we just get to multiply the rest of the numerical values, and so it becomes 16 m to the 4th plus 32 m to the 3rd n plus 24 m squared n squared plus 8 m n cubed plus n to the fourth power. Okay, so let's look at another one. So I have here we have 2x plus y, and that's raised to the third power. So since it's to the third power, if I go back to Pascal's triangle and utilize the third power, it's going to be 1, 3, 3, 1. Okay, I just look back from Pascal's triangle. So now I go over here and say that this is going to be C30 times it by 2x raised to the third power, y raised to the 0, plus C31 times it by 2x quantity squared times by y to the first, plus C32, so this is going to be 2x to the first, y to the second, and then it's going to be plus C33, 2x to the 0 power, and then it's going to be y to the third. So I said that this was 1, this was 3, this was 3, and this was 1. So this turns into what? 8x to the third, and that's just 1. This is going to be 4x squared, and that's y to the first. This is going to be just 2x, y to the second, and then this is just going to be 1 times it by y to the third. So final step is to just multiply it out. So this is where I get 8x cubed plus 12x squared y plus 6xy squared plus y cubed. Okay, so if I look at 6 minus x, again, now it's the fourth power, so it's just like what we used in the previous example. We're using 1, 4, 6, 4, 1. And we can go and say, all right, so I'm just going to, instead of writing C, I'm just going to write whatever these are here. So it's going to be 1 times it by 6 to the fourth times it by, I'm going to use negative x to the 0. So then I can just put pluses here, and then wherever I need to put minuses, I can go about putting minuses from there. This is now going to be plus 4 times it by, because it was 4 up top, times it by 6 to the third times it by negative x to the first, plus 6 times it by 6 to the second times it by negative x to the second, because you're adding 1, plus, now it's 4 times it by 6 to the first times it by negative x to the third, and then it's going to be plus 1 times it by 6 to the 0, negative x to the fourth. So go about solving these. This is going to be 1 times it by 1296, and then this is just 1, because anything to the 0 power is 1. Now I got 4 times it by 6 to the third. 6 to the third power gets us 216. And then this is just negative x plus 6 squared is 36 times that by 6. I get, actually, let's just go 6 times by 36. And then we got negative. So now this is going to be positive x squared here. Plus this is just 4 times 6. And then this is negative x cubed. And then this is going to be plus. This is 1 times 1 times x to the fourth, because it'll be positive. So to finish up, this will be positive 1296. And then because of the minus here, I'm going to say this is going to be minus 4 times 216, which is 864x plus 6 times 36, which is 216, and that's going to be x squared, and then this will be a minus because of the negative, and it'll be what, 24x to the third, and then it's going to be plus x to the fourth. So reason why we use these combination ideas is they're going to sometimes ask you a coefficient for a particular power or a particular value. And so in this case, they want to find the coefficient that will be attached to x to the eighth with respect to this binomial 3x minus 2 raised to the 10th power. So here is how we are going to find out what these values are. So in this particular instance, we are looking at the products of three terms. The first thing is I need to find the combination, and since there are 10 of them, I got 10 objects, and I need to find the arrangements for 8 of them because it's to the 8th power. So that's, I need to find that one product. The next product I need to find comes from this first term of a, which is 3x, and it's going to be raised to the power of what we're looking at here, which in this case is 8. So I'm going to write 8 here. And then the third one is coming from the value of b, which is negative 2. And what power that gets risen to is the difference of 10 minus 8, which is 2. Okay? So if you ever notice, like if you look in previous examples, if you add these up, so like 3 and 0 get you 3, 2 and 1 get you 3, 1 and 2 get you 3, 0 and 3, so they always add up. So that's why that's utilized there. Okay, so looking at the combination of 10 and 8, the result of that is 45. And then over here, 3 to the 8th power is 6,561, and then it's x to the 8th, and then negative 2 squared is positive 4. So I'm just going to multiply all of the terms together here. So it's 45 times 6561 times it by 4. I get 1,180,980 as a coefficient for x to the 8th. So if I were to expand this whole thing, that's where x to the 8th would come in. It would be 1,180,980. Okay, so looking at this example here, we have, they want us to find the coefficient of x to the 5th, where it's 2x minus 7 raised to the 9th power. So again, I got the combination where I have 9 objects, and since I want to raise it to the 5th power, I gotta put 5 there in this particular instance. It's going to be multiplied by a, which is 2x, and that is going to be raised to the 5th power. And negative 7 is the next value here, which is b, and then it's going to be 9 minus 5, so this is going to be raised to the 4th power here. So combination of 9 and 5, the result of that is 126. 2 to the 5th power is 32. X to the 5th is x to the 5th. And then negative 7 to the 4th is 2401. So multiply all those out. 26 times 32 times 2401. I get now 9,680,832. And that is being able to use combinations and the binomial theorem. Hope this helps. Till next time.